All right. Well, welcome back, everyone. I it is my honor to introduce to you this morning Tearina G. Asiata. Tearina is a remarkable person that I've gotten to know over the course of these last 2 years. I am very impressed by her tenacity to challenge herself through her educational endeavors. Tearina came to Hilo as an undergrad to study English. After receiving her English degree and her teaching certificate, she returned to American Samoa to teach English to high school students. While she was home, she decided that she was interested in the medical field professions and also in rapid climate change. And so she decided to seek out an advanced degree in science and return to Hilo as a tropical conservation biology and environmental science graduate student. I am really impressed by this jump from English and English literature and teaching to this deep dive into the sciences. And so now I invite you all to listen to Tearina, and I invite Tearina to share about her experience in epidemiology.
Thank you, Lisa, for the wonderful introduction. Aloha and talofa, everyone. Aloha and talofa, everyone. My name is Tearina Asiata, and I am a second-year graduate student at the University of Hawaii at Hilo. I am pursuing a Master's of Science in Tropical Conservation Biology and Environmental Science. I am originally from the islands of Samoa, but have resided on Hawaii Island since 2013. And so today I will be sharing about my internship experience and of course my project, which is titled The Epidemiology of Mosquito-Borne Diseases in American Samoa. I'd also like to take this opportunity to recognize my committee, Ms. Lisa Canale, who is the TCBES Internship Program Coordinator and my academic advisor, and Dr. Ifili Tufa, who is the Chief Epidemiologist for the American Samoa Department of Health. He also happens to be my project mentor and internship supervisor. And so throughout this presentation, I will be talking about some of the major components of my project and internship experience. There will be a brief overview of the study site, the location where the internship took place, followed by a mention of the factor that is presumed to influence the increased distribution of mosquito-borne diseases. And then the vector, which is the organism responsible for carrying and spreading the infections, followed by an explanation of the transmission process, how the virus is transmitted from the host to the vector and vice versa. Then there will be a discussion of the 4 diseases of concern for the American Samoa Department of Health as to how they came to be, as well as the factors that are influencing their success with regards to survival rates. There will be a mention of how the host agency responds to the issues surrounding mosquito-borne diseases, among other things. And lastly, I will discuss further some of the details involving my internship experience back in American Samoa in terms of additional assessments and tasks that I was fortunate to take part in, along with my experience with some of the local agencies that I had the opportunity to observe as to how their work is relevant to the mission that is set out by my host agency. American Samoa is a Polynesian island located south of the equator, and it's the most eastern part of the Samoan archipelago. It consists of 5 islands, all of which are inhabited. There is Tutuila, Ta'u, Olasenga, Ofu, and Onu. There's also 2 atolls, one of which is uninhabited. All of these islands and atolls make up a total land area of about 76 square miles. And according to the most recent census, which was conducted in 2020, American Samoa has a total population of 49,710. Because of the territory's proximity to the equator, it experiences a tropical climate all year, consisting of wet summers and dry winters. And Tutuila being the largest island, it has a total land area of about 50 square miles and is home to more than 90% of the total population. And so Tutuila is where the host agency, the American Samoa Department of Health, is located and where the internship took place. Climate change has recently become a growing concern globally. For many centuries, the climate was perceived to naturally shift from one state to another, that being warm to cold and vice versa. But for the past few decades and counting, the global climate has remained in a warming state. And although there are natural factors which are said to influence this change, there is also evidence that validate the claim that human activities, particularly activities involving the use of fossil fuels, have been the dominant cause of the recently experienced warming. And so the question still remains, how does climate change influence the increased distribution of mosquito-borne diseases? Or what role does climate change play in the issue regarding or surrounding mosquito-borne diseases? Well, as a result of climate change, temperatures constantly rising, and as the temperature rises, so does the likelihood of precipitation, which is ideal for mosquito breeding. And not only do they thrive in warmer temperatures, they also breed in wet environments, which means that frequent precipitation will only provide them with additional breeding grounds, allowing them to not only increase in population size, but also in terms of geographical spread. So current research has largely focused on the global effects of climate change on vector-borne diseases. And this actually sparked my curiosity as I was driven to study science after learning about the severity of mosquito-borne diseases in American Samoa. And so American Samoa was selected as my research location because it was an area I knew was struggling with the emergence of new diseases, as well as the reemergence of old ones, particularly mosquito-borne diseases. Also, the mosquito species that are known to be the primary vectors for diseases are present on the islands. And since American Samoa has a tropical climate year-round, it made it the right fit for this type of project. Furthermore, towards the ending of last year, a climate change report created for American Samoa by the Pacific Islands Regional Climate Assessment was published. This assessment reviewed some of the climate indicators for American Samoa, which included air temperature and rainfall. So what they did was they collected and analyzed the territory's air temperature and rainfall data for the previous 50 years. And the general trend showed that the average temperature from 1967 all the way to 2020 was 80.6 degrees Fahrenheit. In addition, they broke down the data for air temperature into hot days versus cool nights. The data indicated that hot days being 90 degrees or higher, increased from an average of about 9 days per year in the first decade to an average of about 22 days per year in the last decade. And cool nights being 73 degrees Fahrenheit and lower, have declined from approximately 85 nights per year in the first decade to an average of about 4 days per year in the last decade. And rainfall, on the other hand, based on data obtained on rainfall, it appeared that rainfall had increased. However, future rainfall projections are still uncertain. Now that we know how the climate influences mosquito population, let's get into mosquito as a disease vector. And so mosquitoes are considered harmful insects all across the world. They are said to have originated in South Africa and spread throughout the world. There's about 112 genus and approximately 3,000 mosquito species found worldwide. At least 12 of the mosquito species have been recorded in American Samoa. From the point of view of human health based solely off of American Samoa data, The most significant genus is the Aedes. Mosquitoes belonging to the Aedes genus are the primary vectors for mosquito-borne diseases in American Samoa. The 3 Aedes species that have been identified as primary vector for diseases in the territory are 1, the Aedes aegypti, and this particular mosquito is known to transmit 3 of the 4 diseases of concern, which are chikungunya, dengue fever, and the Zika virus. The second mosquito species is the Aedes albopictus, which is commonly associated with chikungunya and the Zika virus. And the third one is the Aedes polynesiensis, and this is the primary vector for lymphatic filariasis. It is also known to carry dengue fever infection. And so these mosquitoes are responsible for transmitting infections, which has resulted in high morbidity and mortality rates across the globe, including American Samoa. I also wanted to highlight that mosquitoes are not born vectors. They actually go through 4 different phases. There's the egg, and then they transform into a larva and then a pupa before they fully transform into adults. At this point, only adult female mosquitoes become vectors as they require blood meals in order to reproduce. Male mosquitoes only feed on plant nectars and juices, so that makes them less threatening to humans compared to female mosquitoes. Mosquitoes also have a lifespan of 2 to 4 weeks. And so transmission has to occur within that time frame. Transmission occurs once an uninfected Aedes mosquito bites a person that is already infected with a virus that causes one of the 4 diseases of concern. And so once the mosquito is infected, they will remain infectious for the duration of their existence, and they will be able to infect many other humans. Transmission cannot spread directly from person to person. There needs to be a vector involved. And also, the only way these diseases are transmitted geographically is through human travelers. And so the diseases of concern carried by these vectors that I've been focused on are dengue fever, chikungunya, Zika virus, and lymphatic filariasis. These diseases are classified as zoonoses under the American Samoa Department of Health Notifiable Disease Catalog. Zoonosis is simply a classification for diseases that are transmitted to humans by animals. So these mosquito-borne diseases are extremely hazardous and are affecting a variety of regions across the globe, with some locations being more impacted than others. According to estimates by the World Health Organization, mosquito-borne diseases kill approximately 700,000 people annually. Now, moving into discussing each disease of concern separately. The first one is dengue fever. This disease has been listed as a major public health concern. It is caused by one of the 4 dengue viruses that belongs to the Flaviridae family. All 4 viruses have been identified in Asia, and this is why it is thought to have originated there. The primary vectors, like I mentioned earlier, are female Aedes aegypti and Aedes polynesiensis. Dengue fever is most common in tropical and subtropical areas. And although dengue fever outbreaks have occurred and continue to occur in parts of America, Africa, the Middle East, Asia, and including the Pacific Islands, evaluation of dengue occurrences indicate that population of some African countries, namely Somalia, Kenya, and Tanzania, is severely impacted by this disease. And so dengue is characterized by these symptoms that are shown on the diagram, which was adapted from the Centers for Disease Control and Prevention. Dengue fever was originally described in American Samoa in 1972 and is now assumed to be endemic. And the accuracy of this endemic assumption was tested after a dengue serosurvey was conducted in 2010 in response to a dengue 4 outbreak in 2009, which revealed that 96% of the people of American Samoa had previously been infected with dengue. So the last dengue outbreak in the territory was in March of 2017, and it lasted up to May of the following year, 2018. And so the second disease is chikungunya. This disease is caused by an infection that is also related to the Filariidae family of diseases and was first identified internationally in 1952 after an outbreak in southern Tanzania. And so the term chikungunya is derived from a Kimakonde expression, which is a language spoken by an ethnic group in Tanzania that translates as to become distorted, which sort of describes the pain experienced when infected by the disease, especially when considering the most common symptom of the disease, which is joint discomfort. And so the CDC adopted map depicts current and previous local transmission of chikungunya. And the areas that are shaded with the darker green are located within the tropics and subtropics. This could imply that the climate in this area influences the disease or its vector. And so chikungunya was first discovered in American Samoa in 2014, when reported cases related to this disease had reached over 700. And so there has been no indication of an outbreak recently, and there's no further update. No further update has been made about this disease in American Samoa. The third disease of concern is Zika virus. The Zika virus is closely related to the chikungunya and dengue fever, as they all originate from the same family of pathogens. It was initially identified in Africa during the 1940s to the 1950s, with few reports of infection in humans up until recent years. Most people infected with Zika don't develop symptoms. If they do, they will experience symptoms as shown on the diagram. In some cases, the virus can cause devastating birth defects if it infects a pregnant woman. And so the Zika virus has been associated with neurological abnormalities in newborns born to infected expectant mothers, which causes increasing muscle weaknesses and can lead to temporary paralysis and microcephaly, which causes developmental delays. And so, according to the chief epidemiologist, there was a Zika outbreak in the territory in February of 2016 all the way to March of 2017. And so an assessment conducted recently in 2020 for American Samoa by the International Association for Medical Attention to Travelers to follow up on Zika cases, the report stated that there was no Zika transmission in the territory and no indication of an ongoing outbreak. But then again, there was inadequate data and new cases could be detected and reported slowly. The lymphatic filariasis is a parasitic infection. This is commonly referred to as Elephantiasis. This disease is caused by worms that are transmitted and released by infected mosquito bites, most commonly the bites of the Aedes polynices. These worms are called I never get this pronunciation right, Wackaria bancrofti. And these worms stay in the lymph system and they can live up for about 4 years and produce microfilariae. And so this disease causes damage to the lymphatic system, which then causes swelling in specific body parts, hence the term elephantiasis. And these swelling of body parts will result in pain, social stigma, and acute disorder. And so I want to emphasize that this disease is very severe, as it has been reported to infect over 120 million people worldwide, with an additional 856 million people at risk of infection. And so the history of origin for this disease is unclear. There were scientific documentations discovered in Africa, Asia, and the Middle East dating back to the 1800s of what appears to be lymphatic filariasis. There is also Egyptian tomb carvings that date back to 1500 BC that indicate that people living at the time may have been affected by lymphatic filariasis. Similarly, there is photographs dating from 1100 to 1200 in Japan that also show people suspected of having this very illness. And so in 1997, this was during the 50th World Health Assembly, a resolution was called and approved to eliminate elephantiasis as a public health issue. And so later in 1999, a coalition to eradicate lymphatic filariasis, known as the Global Program to Eliminate Lymphatic Filariasis, was formed with the goal of ridding nations of lymphatic filariasis by 2020. And so following the formation of this program, a mass drug administration was developed, which significantly slowed the spread of elephantitis in American Samoa, while also controlling the spread and suffering of those who had already been infected. And so despite these efforts, transmission still continued, and study surveys that were conducted in 2010, 2014, and 2016 indicated that new infections were still occurring in both children and adults. And so following that incidence rate in 2016, with the addition of more transmission hotspots and an evident revival of infection rates, these factors prompted the implementation of the triple treatment method. And this round, the first round of the treatment was distributed in 2018. And so according to CDC reports, which were reviewed and updated in September of last year, states that American Samoa remains the only location in the United States where one could become infected with lymphatic filariasis. And so American Samoa continues its efforts of battling this disease. Lymphatic filariasis and the mass drug administration has been the verdicts of my internship experience. In October of last year, the American Samoa Department of Health kicked off its third round of mass drug administration for lymphatic filariasis. And so the campaign was funded by the Pacific Islands Health Officers Association. And the campaign aimed at getting the majority of the eligible population to take the medication that is supposed to help prevent the worms causing lymphatic filariasis from harboring in your system. And note that this method is not a cure. Once you have been infected with lymphatic filariasis, you will live with the infection for the duration, like your entire lifetime. And so the point of the pills is to prevent more individuals from catching this disease. So it will only help protect those who haven't been infected. And so the teams for lymphatic filariasis for the mass drug administration systematically distributed the drug house to house from the west side of the island, moving towards the east side of the island. And this was to ensure that they reached the maximum eligible population. There were also teams assigned to the Manua group and Oahu Island. And so the dosage for each individual was dependent on their weight. With the exception of 2 to 4 year olds, there was a fixed count of pills for this age group. And so the graph on the upper right-hand corner, this disclosed the total number of participants, meaning the people who took the pills, by a dosage letter. So each letter represents a certain weight range, and the letter also determines how many pills a person must consume. And the graph on the bottom right-hand corner discloses the total number of doses administered by age group. And so 5 years to 14 years was the age group with the highest count of participants. And so the pie chart simply separates total count of participants by sex. And all these graphs were provided by the American Samoa Department of Health. And so in the end, approximately 16,000 residents of American Samoa were able to take the medication. And so that's about 32% of the total population. And that was quite an achievement by the American Samoa Department of Health, most especially the PIHOA, the Pacific Islands Health Association, Officers Association, and the Lymphatic Filariasis Task Force. And so aside from the mass drug administration, the American Samoa Department of Health had also conducted other initiatives in response to the mosquito-borne disease predicament in American Samoa. ASDOH, the American Samoa Department of Health, had partnered with other relevant entities in the previous years, including the Office of the local entomologist, in efforts to further study and understand the distribution of mosquito populations in American Samoa. There were also mosquito control efforts conducted in the past, including a survey conducted in the villages where residents of villages surveyed were encouraged to remove any items that could hold water that could provide breeding spaces for mosquitoes. And so the success of that particular initiative really was dependent on the community level and their efforts to participate. So another control method was the introduction of a new mosquito species. It's called tox, that is said to eat the larvae of other mosquito species. And this was another mosquito control effort that was introduced to American Samoa. And so during the time of my internship, there was no ongoing mosquito efforts done by the local entomologists, as there were other invasive species that were pursued at the time. And so the American Samoa, another effort in response to the mosquito-borne disease situation in American Samoa is that the American Samoa Department of Health continues to closely monitor diseases occurrences in the territory, ensuring that the department stays ahead of these emerging and re-emerging diseases. And so community outreaches are also conducted to continue raising awareness on the severity of mosquito-borne diseases, as well as prevention measures that can be taken. And so some of the additional opportunities that I was fortunate to observe and participate in included the vaccination campaign for COVID-19. So my entire internship experience occurred during a time when the world was battling with the pandemic, and American Samoa was one of the places in the world that was COVID-free. And so with my mentor being the point of contact for all things disease related, I had minimal time to observe and learn directly from him. But these limitations turned out to be the best, as it really helped shape my experience and led me to meeting and working with other professionals in the field, which not only expanded my network, but also my skill sets and understanding. And so in addition, I was also allowed the opportunity to work and observe the water quality team at the American Samoa Environmental Protection Agency. They also dealt with different pathogens that are also under the American Samoa Department of Health radar, but the data is collected and tested at the American Samoa Environmental Protection Agency lab. And so the pathogens that they deal directly with are more waterborne pathogens. And so the internship experience and my project allowed me to expand my understanding in my field of interest. I can say that I have learned a lot about mosquito-borne diseases in American Samoa throughout the duration of my internship. And so this experience has also helped me realize that a lot is still to be discovered about climate change and how it impacts the distribution of mosquito-borne diseases. And the lack of data availability is only one of the problems. Funding and people with the required skills and knowledge would really help make some progress in the right direction. Also, data on distribution and abundance of infected population is needed in order to make some sort of indication as to which areas are more affected, and from there, more determinations can be drawn. And lastly, most of these mosquito-borne diseases have very similar symptoms and can easily be mistaken for each other. Therefore, future research must be conducted to further understand and distinguish these different diseases. And so I'd like to conclude today's presentation by acknowledging everyone who has contributed to the success of my internship experience and project. Dr. Tufa of the American Samoa Department of Health, Thank you for enabling me to work with you in the department, which allowed me to see the reality of the obligations managed by the department on a daily basis. I'd also like to thank Dr. Schmidt for sharing your knowledge on mosquitoes in the area. Also like to thank specific individuals from the American Samoa Department of Health, Lynette Soyono Scanlon, Jackie Stolaitza, Joshua Nasiri, Mata'aufai Ayan Ulapele for ensuring that my internship goals were met and for establishing extra projects and programs for me to observe. I'd also like to thank a few American Samoa Environmental Protection Agency employees, Simpuka Faiwaso, Daystar Parker, Leilua Watson, Kimo Makiasi, and Laukau Otu Afi, and Lily Famuina for allowing me to learn from you all about the Water Quality Division's efforts to ensure the safety of all recreational and drinking water sources. I'd also like to thank my advisor, Misa Kanale, for supporting and guiding me throughout the past 2 years of my graduate journey, making sure that my professional goals and aspirations were fulfilled. I'd also like to thank the University of Hawaii at Hilo, the Tropical Conservation Biology and Environmental Science graduate program, mainly the 2020 cohort, for making the last 2 years of this graduate school experience memorable. And lastly, I'd like to thank my family, both here and back in American Samoa, for supporting me in every aspect of my educational journey. With that said, I want to thank you all for listening, and yeah, I'll take any questions.
All right, thank you so much, Tearina. I'd like to open up the floor for questions. If you have one, please go ahead and unmute yourself. And if we get a line, go ahead and use the raise your hand icon. And don't be shy. Okay, John, please feel free to unmute yourself and ask a question.
Yeah, awesome job, Tearina. That was so great. I'm super curious about, repeat the name for me. I think it's something filariasis.
Lymphatic filariasis.
Lymphatic filariasis. So I did not understand the scale that was working at. I think you said something like 120 million people are infected worldwide.
Yeah.
Does that sound right?
Yeah, 120 million people affected worldwide, with 856 more that are at risk of infection.
That's awesome. Yeah, mostly I just wanted to have you highlight again the fact that you were a part of this distribution process for the pills, right? To help prevent filariasis. And I think the numbers when we were going over your slides, it was like pretty incredible. Like you had reached something like 20 or maybe even 25% of the population of the entire island, or the entire nation rather, which is pretty amazing. I just wanted to say big ups, incredible work. Yeah, and keep doing what you're doing.
Thank you, John. Thank you for that.
All right, Jessica, please feel free to unmute yourself and ask your question.
Great job, Tearina. That was awesome to hear all about your internship. I'm wondering what the most rewarding part of your internship was.
For me, it was, aside from being home after 2 years of being away from home, it was actually expanding my understanding on the issues regarding mosquito-borne diseases. I didn't quite mention this in my presentation, but my initial research, my initial project was to evaluate the accuracy of the assumption made towards climate change and its prospective influence on the mosquito distribution in American Samoa. And so part of that, the project was unattainable, and there were certain limitations that caused that to not be attainable. There was obviously, it was kind of difficult to measure the distribution and abundance of mosquito populations in American Samoa. And so that led me to focusing more on each disease rather than, the distribution. And so I feel that the transitioning from like a sort of like a failure and like initial project to like something that was more rewarding. I think that was more rewarding for me.
So I like to call that pivoting. So that was a pivot to a more rewarding opportunity for you. So I have a question for you regarding to this, like what your understanding is of LF, and that how, given the distribution success that you had, how many more years do you think that the Department of Health will need to run those kind of programs to really see a decline in LF on the island?
That's actually a good question, Lisa, because as I was reviewing some of the statistics by other countries, and so one of the things that was pointed out by the global program to eliminate lymphatic fever virus was that countries who they need to achieve 65% or more of people to participate in taking this this drug, and that would be a step closer to eliminating this this disease in the country. So I hope that answered your question.
And you were able to reach, what did you say, 30% of the population?
36%.
So do you think that doubling the efforts would make that difference, or do you think that there are other barriers to reaching that goal of more than 60%?
Yeah, most definitely doubling the effort, given that this effort was done like in a span of 6 weeks. I think that more weeks could have been, could have really changed that, the stats in the population of, and the number of participants, I would say.
Thank you. I'd like to turn the floor over to Becky for her question.
Hey, Becky.
Yeah, thank you so much, Tearina. That was cool to see how you've taken your work back home. I was wondering, you were really successful in the distribution. Do you see barriers in people's attitudes towards disease and the treatment? And if you could talk about a little bit about that, or are people generally accepting about treatment and other issues related to that?
Oh yeah, I think skepticism is a major one in getting there's always people who are skeptical about efforts, even with the vaccinations. And so like for lymphatic filariasis, I would say that one of the things that could be done is to continue raising awareness and, get people educated about the severity of these diseases. And maybe that will sort of like convince them into, persuade them into taking the pills. Because this is the effort is very important, because what I've learned from all these diseases is that they don't have any cures yet, but there are prevention measures to take, to alleviate the issue. And so one of the problems that I experienced when we did our outreach to the villages was that people would say that they've taken the pills, but in actuality they haven't. And so part of it was, skepticism. They don't really think that it's effective. And so, yeah.
Okay. Yeah, thank you.
All right.
Yeah.
Go ahead, Becky. I'm sorry.
Oh, just any ideas how to combat that skepticism? I think that's the million-dollar question for so many things these days.
Yeah, like I mentioned, continue raising awareness, and that could be drawn down to like a smaller community. I would say maybe do village by village outreach, or it could be outreach could be taken to the school settings. Say, for instance, that this is educate, like information on these diseases are taught to a younger generation, and maybe then that could, stir some persuasion in a higher or older group of individuals.
Okay, cool. Thank you. Those are good ideas.
All right.